Hello viewers, a very warm welcome to you. This is TV, the voice of humanity. Today, I have with me in the studio is Dr.Rayyan Mamuda Dodo from the Department of Metallurgical and Materials Engineering, Ahmadu Bello University, ZARIA. You are highly welcome to the show, sir.
Thank you very much.
As a lecturer in the profession, Metallurgical and Materials Engineering, what is the field all about?
Thank you for giving me the opportunity. My dear viewers, good day to you all. Metallurgical and materials engineering is a field of engineering. It's another field of it's one of the fields of engineering which deals with materials and how these materials can be converted into products that benefit humanity. The benefits can be by using the materials to produce the following. Number one, surgical implants. Number two, cars. Number three, aeroplanes, and so on. It is important to note that this field of engineering divides materials into three categories. The first category is called metals/alloys. The second category is called ceramics, and the last one is called polymers.
Okay.
Metals/alloys. We all know what a metal is. For the alloy or alloys, alloy is a solid solution of a metal with another metal, or a solid solution of metal and a non-metal. To a layman, it's just a mixture of metal and a metal, or of metal and non-metal in solid state.
Okay.
That's why in my definition, I said solid state.
Okay.
I mean solid solution. Solid solution of a metal with another metal, or solid solution of metal with a non-metal. Okay. The second category, which is called ceramics. A ceramic material is a material which is an inorganic and non-metallic solid that is made of either metal or non-metal compounds. For example, silica, or let me say sand. Sand is a ceramic because it is what you have there is just silicon oxide or silicon. Okay. That's why in my definition I said compound of metal or non-metals. You can see silicon is a non-metal. And another example of ceramic material is clay. Clay. What you have there in clay, I mean, the major constraint there is alumina. And you can see that alumina is also a compound of aluminium and oxygen. And the last category of materials, which is polymer. Polymer is a polymeric material. Is a material that consists of long chain giant hydrocarbons that are assembled from smaller units called monomers. An example of such category of material is rubbers. Rubbers, you know, we have synthetic rubber, we have natural rubbers. We also have plastics. They are all of these. They are under this third category of materials. Apart from these three categories, we have another group of materials called composite.
Okay.
Composite, even from the name, it is composed of two of these categories of materials. That's why it is called composite.
Okay.
It's likely you have a composite made from a metal and a polymer. For example, automotive tires.
Okay.
It's an example of that.
Automobile car tires.
Yes, car tires. They are made from synthetic rubbers. Synthetic rubber is a polymeric material, and what you have inside the tires is still wires. So you could see here we have a metal. We have a combination. Yes, we have a combination of metal or alloy and a polymer to produce a unit material. Another example of composite is concrete. Concrete is also another example of that. What you have in the concrete is steel rods, and then the gravels, the cement, and the rest. They are part of the ceramic. Again, it is interesting to know that this field of engineering is being divided into three fields: process metallurgy, physical metallurgy, and materials processing and engineering. For example, when you have an ore deposit, and if a mining engineer comes to that place and gets the ore from the earth crust, that is excavated from the earth crust, when that excavation is done, now the mining engineer will now hand over the run of mine ore, that's the name we call it, to the metallurgical and materials engineer. Then the metallurgical and materials engineer will now use the knowledge he has in this first discipline of metallurgical and materials engineering to process the ore to its final product. And when that is done, now still the metallurgical and materials engineer will now go ahead to now use the knowledge of the physical metallurgy to improve the properties of the finished product. For example, we now produce steel at the end. Let's assume we started with iron ore. So at the end, we got steel. You can either get steel or cast iron, depending on what you want to produce. So when you have steel at the end, now you want that steel to be used in marine environments. Of course, as a metallurgical and materials engineer, you must think of the specification of that marine environment. And ordinary steel cannot be taken to that marine environment. You have to maneuver some things.
Okay, before you get into that.
Before it can work the way you want it to work. One of the specification, or one of the requirement of that environment is the material you want to use in that must have high corrosion resistance. Okay. So for you to now make your ordinary steel to have that property, you must alloy.
You need alloy.
You must alloy. That means you must add another metal. Okay. To make your steel have that property. You understand? So a metallurgical amateur will now use the knowledge he has in this second branch of metallurgy to add chromium, for example, because chromium has that property. Resisting corrosion has that property. So a metallurgical and materials engineer will now use the knowledge he has in this second branch of metallurgy to now add chromium to the steel so that it can have that property. And after that, of course, maybe your steel does not meet with the requirement of maybe hardness and strength because it is a marine environment. For example, you want to build hull of the ship, the body of the ship. You need a material that has high hardness, and you need a material that has high strength. Then you go for heat treatment. You understand? Now, for the third branch of metallurgical engineering, that is the third discipline. it is all about materials processing and engineering. Let me give you an example. Many patients now are running away from dental implant made from metals. That is metallic dental implant. Why? Because metals have higher thermal conductivity. So whenever you take hot meal, that implant now becomes hot.
Okay.
You understand?
So
And
the tooth,
yes, that heat,
metallic teeth.
yes, that heat will now create uncomfortable sensation to the patient. So that's why many patients are now running away from that, from implant made from metals or from alloys. So now you could see that now a challenge is put before a metallurgical and materials engineer to now produce a material
To substitute.
or to develop a material that will have properties similar to metals, but is not having that high thermal conductivity. Of course, the only categories, the two remaining categories of material we have at hand is ceramics and polymers. Ceramics, of course, they can work in that area of applications, but the only problem with ceramics is that they are too rigid. They have higher modulus of elasticity. And of course, in that area of application, we want a material that has moderate modulus of elasticity so that it can be compatible with the bone jaw.
The jaws of human.
Yes. So that when chewing is taking place, there is going to be a compatibility between the two components, the two parts, in the human mouth. You understand? So that is the problem with ceramics. You could see that it is too rigid, even though it has high strain, high hardness, and so on. But the modulus of elasticity is a source of concern. And in addition to that, they have their toughness is very low.
Okay.
Their toughness is very low. We want a material that can absorb impact, high toughness.
What of the polymer?
The polymer, yes. The polymer, them too, they can work. But the problem with them, with that category of materials is they are soft.
Very soft.
They are very soft. Okay. And at the same time, they are not strong. We want a material that is strong in compression. When you select that material in compression, it will be strong. But polymers are not that strong in compression. So this means that it is a challenge to you to now think of how to combine these two materials so that you can come up with a material, yes, with a material that
less difficulties to
yes, with a material that can work perfectly in that area of application. That's why in my previous explanation, I made mention of composites.
Yeah, composite.
So at this junction now, the best candidate for you is composite. Produce a composite from these two categories of materials, ceramic and polymer, so that you can have a material that can work in that particular area of applications. So for you to now do that, a metallurgical and materials engineer must use the knowledge of these third disciplines of metallurgical and materials engineering. Yes, that is it about the.
It's very interesting area.
Yeah.
It's a little more broad. It's very broad, I would say.
It is very yes. Brief. That is all about the.
We will be interesting. We will be keen interesting to hear how did it start as professional in Nigeria.
The history of this profession can be traced to the establishment of the steel industries in Nigeria. That is government-owned steel industries in the country.
Okay.
At that time, the then government awarded scholarships to young Nigerians to go and study it abroad.
It is about what year are you referring to?
Yes, it was in 1976.
1976.
Yes. In 1976, government awarded scholarships to young Nigerians to go and study abroad because the government then had a plan of establishing government-owned steel industries. These steel industries were three
at that time.
at that. Yes, that is the plan. The plan of the government then was to establish three steel industries.
That country.
Yes, and the dream of the government became reality in 1979 because the government at that time started constructing the three steel industries in conjunction with a company owned by Soviet Union.
Oh.
The three industries were Ajakuta Steel Company at Ajakuta, National Iron Ore Mining Company, Itape, and Alaja Steel Complex, Alaja, in Delta State. So in 1979, many of these young Nigerians returned home, graduated from foreign universities with the degree in this metallurgical and materials engineering. So majority of them were employed. So they were part of the construction project.
Was their performance outstanding?
Yes. Yes, the performance was outstanding then because the government was really serious at that time.
Okay.
The government, because of the level of its seriousness, went ahead and even established 3 metallurgical training centers. These metallurgical training centers were saddled with the responsibility of producing middle-level manpower for the newly established steel industries. So at that time, really, the government was serious. And so in the early 80s, the construction projects reached an advanced stage. So all of these 3 steel industries began production. Many of metallurgical engineers were part of that production. And majority of them registered with the CORE, that is the council that regulates the engineering profession in Nigeria. So at that time, the profession became fully known to the engineering community in the country.
Yeah, very interesting. But with all the manpower and the experiences of the graduates with their experience we have, why is it that many, or I should say, indigenous steel industry are not functioning in the country? How does that?
Yes, you could see that I made mention how it all started. Yeah. That is the government, because had plan of establishing steel industries. That's why it awarded scholarships to Nigerians to go and study it abroad. But now, why is it that we have enough manpower, enough metallurgical and materials engineering professions, enough metallurgical and materials engineering engineers, but still the steel industries are not functional?
The government, for example,
government-owned steel industries, yes, are not functional. You see, there are many factors as to why this is happening. I'm going to mention only 2 factors. Number 1 is the first factor is the government behavior towards revenue generation. That is number 1 reason or factor. You see, governments, both the past and the present government, both the past and the present, considers oil as the major or reliable source of revenue
to
Nigeria.
Since the emergence of oil.
Yes. But the government failed to understand that the only sector that is reliable in revenue generation throughout the world is steel. Take, for example, Japan. Japan, they doesn't have oil. Japan doesn't have oil, sorry. Japan doesn't have iron ore deposit. Even the iron ore deposit we have in abundance everywhere in this country, they don't have it. Japan has to import the iron ore from foreign countries, process it in their country, and then take it to the oil market to sell it. And you could see they are among the G7 nations. The economy is strong. It's among the strong.
But this government seems to stress on agriculture. Do you think that is one way to stress on agriculture? It seems that this present government stress its economy and reviving the agricultural sector. With all the insecurity they have been facing, challenges of insecurities.
You see, in my own opinion, the government doesn't need to initiate all this empowerment program, credit loan for farmers, empower trader money,
Micro-scale businesses.
and so on. In my own opinion, all the government needs to do is to invest that money in the steel sector.
So you mean Nigerians, we need more stress. For example, in agriculture, we can see that the government puts more effort to revive the agricultural sector. So we need that in the steel industry.
In the steel industry, in my own opinion, if the government invests in that money, if the government invests money in that sector, the steel industries will be functional, and we will be able to have our own steel, locally made. And with that steel,
We can export.
with that steel can be used to fabricate or to manufacture farm implements. And when we have that farm implement available in our country, even the government can subsidize the farm implement without any difficulty. And once our farmers have that available to them, what do you expect? All our local farmers.
Farming will be easy, much
Farming
easier.
will be easier for them. And even to do it at large scale, it will be easier for them. And that will be what? Boost in the agricultural sector.
And even production of automobiles, right?
Yes.
That's
Again, if we have a strong steel sector, if we are producing our local steel, that steel can be used to produce surgical implants for our hospitals, even the equipment we are using in our hospitals. That means our steel sector, our health sector, will be also strong. Again, we can use the steel to manufacture ammo tanks, magazines, rifles, and so on. So this means that even our defense industry will be strong. So you could see that it cut across nearly all the sectors of the economy.
So it is one of the most, if not the best.
Yes, in my own opinion, if the government can invest in that, before you know it, a lot of people will get work to do. They will even because the economic activities will be
Economy is going to boost it.
is going to boost the economy. So the economic activities will be high compared to what we are seeing.
Unemployment.
Will be reduced because even the steel industries will now.
Because they need manpower.
Yes. They will employ a lot of our graduates. Understand? And there are other industries that are dependent on the steel industries, so they will be getting their raw materials at ease. You understand?
So you made mention of interesting points, and so I'm not sure. What's your conclusion and any suggestion for the government?
Yes, I said before the conclusion. I said, in my opinion, two factors are the reason why our steel sector are not functioning. The last reason, or the last factor, is the government behavior.
The interest of the government.
No, the government doesn't believe in indigenous metallurgical and materials engineers. Not even metallurgical and materials engineers. In fact, in most cases, you will see that our government doesn't believe in our indigenous professionals. It doesn't believe in our indigenous professionals. You understand? The government can decide to make 100 MOUs with the Chinese, with the Indians, with the foreigners. Yes, with the foreigners to come and fix the companies. But that will never work. That will never work. Because it is only the indigenous engineers that will now have that patriotism. You understand? That will have that patriotism and develop the sector. You understand? So all the government needs to do is just to empower our indigenous professionals, especially in this sector, metallurgical and materials engineers. Just give them all the support they need. both the financial support, the equipment, facilities, everything. Once that is done, I'm sure our steel sector will be revived. So the government has to make a U-turn, has to believe in the indigenous metallurgical amateurs engineers.
In a nutshell, the government has to believe in its citizens.
In its citizens.
Their capacity.
This is our home. This is our home.
Nigeria.
Yes. So it is only we. You know, technology is secret. You can't expect a foreigner, a Chinese or an Indian to come and share the secret he has for you to develop. We have to stop deceiving ourselves. It is we that will develop our own technology. It is we that will develop our own steel sector, not Indians, not Chinese, not
Americans. So, at the initial, what's the conclusion?
My conclusion is that I want to use this medium to tell the government or let the government know that there is no a single nation that develops at the present time without having a functional steel sector. Without having a functional steel sector. So if the government is really serious in developing the economy of this country for sustainable development, the steel sector has to be functional. And my suggestion to the government is that the government should invest huge amount of money. The money that's required to make the steel functional, to make the steel industries functional. When that is done, then the government can declare, as a suggestion, in my own opinion, the government can declare state of emergency in the sector. Anyone found guilty or corrupt can be dealt with without taking the person to the court.
So it's very interesting idea, but our youth who are listening to us would like to see how is it interesting to apply this course in university. Do you recommend metallurgical and materials engineering for them in universities?
Yes.
How easy it is and how interesting it is,
you see,
to study metallurgical and materials engineering as a lecturer and doctor in the profession.
You see,
so they're keenly interested to.
Yes, it is good. You see, this field of engineering is very interesting. You see, any engineering field you can think of, that engineering field, you cannot do anything in that engineering field without having an input from metallurgical and materials engineering field. Let me give you an example. For you to produce a car, we all know that it is now the work of mechanical engineers that will assemble all the parts, components together to produce the car.
Yeah.
But those components,
the materials,
for example, the block engine, who will produce the block engine for the mechanical engineer to use? It is the metallurgical and material engineer that will produce the block engine. So even the material used in producing the block engine, which is cast iron.
Even the tools, the mechanic will use the tools. So
even the tools, they are made from alloys or metals, which of course it is the metallurgical and materials engineer that process them from the ore.
So it is the backbone.
It is the backbone of the engineering.
Backbone.
It is the backbone of engineering.
It's very well shown.
For example, the chip all these communication companies are using is silicon chip. So it is the metallurgical and materials engineer that process the silicon. They process the silicon up to its final form for you to get the chip. So my encouragement to our youth is, and especially those that are applying or that want to get admission into universities, to please apply for this course. If you study this course, the sky will be your limit.
So it is very well filled, you will say.
Of course. And it is, we have that optimism that in the near future, government is going to do the needful in the sector. Yes, our still sector is we are hoping that in the near future is going to be improved by the government.
So thank you very much, Doctor, for this interesting information you have given us. I will say a powerful lecture, I will say in a nutshell. They have given us about metallurgical and materials engineering. Thank you very much, our viewers. Thank you for being with us all the time. This UTV online, the Voice of Humanity. My name is Lydia. Stay with us all the time. I say goodbye for now.